Hello everyone, I welcome you in the session of Expansion of Functions Part 3. This is SNikam, Assistant Professor, Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. At the end of this session, student can able to solve examples of limits by using indeterminate forms. Now let us see what is this indeterminate form. Introduction. Back in the chapters of limits, we saw methods for dealing with the following limits. Limit x tends to 4 of numerator x square minus 16 divided by x minus 4. And another example is limit x tends to infinity, numerator 4x square minus 5x divided by 1 minus 3x square. Now, if you carefully observe the two limits, in the first limits, if we plugged in x equal to 4, we would get a 0 by 0 form. And in the second limit, if we plugged in infinity, we would get infinity upon minus infinity form. Yes? Both of these are called as indeterminate forms. The topic of this section is how to deal with these kind of limits. As already pointed out, we do know how to deal with some kind of indeterminate forms already. For the two limits above, we work them as follows. For example, let us consider the first one, limit x tends to 4 of numerator x square minus 16 divided by x minus 4. So, here we will factorize the numerator as x plus 4 into x minus 4. Now, one of the factor is common, it is present in denominator also, so we will cancel out it. And now, substitute the value of x to be 4 and hence you will obtain limit x tends to 4 of x plus 4 to be equal to 4 plus 4, that is 8. Dear friends, please pause your video for a minute and evaluate this simple limit. So I hope you have finished with it. The solution comes out to be limit x tends to infinity of 4x square minus 5x divided by 1 minus 3x square is equal to, so that we will get the limit x tends to infinity as x square into bracket 4 minus 5x upon x square whole divided by x square into bracket 1 minus x square minus 3. Cancelling this x square present common in both numerator as well as denominator, left out with 4 minus 5 by x divided by 1 upon x square minus 3. So, if we put infinity directly in place of x, it is 4 minus 1 by 5 by it is 4 minus 5 by infinity, and from in denominator it is 1 by infinity minus 3. But denominator has infinity term which goes to the but the 5 by infinity goes to 0 as well as 1 by infinity also goes to 0. So, the result is simply minus 4 by 3. In the first case, we simply factored, cancelled and took the limits, and in the second case, we factored out x square from the numerator and denominator and took the limit. Notice as well that none of the completing interest or rules in these cases won out. That is often the case. So, we can deal with some of these. However, what about the following two limits? Let first one, limit x tends to 0 sin x upon x, and number 2, limit x tends to infinity e to the power x upon x square. So, if you observe the two limits, for the previous tricks we cannot apply in these two examples, that is factorization or taking few terms to be common. It will not help in this example. So, the first is 0 by 0 indeterminate form, but we can't factor this one, and the second is infinity by infinity indeterminate form, but we can't just factor an x square out of the numerator. So nothing that we have got in out bag of tricks will work with these two limits. So we will define determinate and indeterminate forms as an undefined expression involving some operations between two quantities is called a determinate form if it evaluates to a single number value or infinity, while an undefined expression involving some operations between two quantities is called an indeterminate form if it does not evaluate to a single number or infinity. Let us define limits of indeterminate forms 0 by 0 and infinity by infinity. A limit of a quotient limit x tends to a f of x upon g of x is said to be an indeterminate form of the type 0 by 0 if both f of x goes to 0 and g of x goes to 0 as x tends to a. Likewise, it is said to be an indeterminate form of the type infinity by infinity if both f of x tends to plus or minus infinity and g of x tends to plus or minus infinity as x tends to a. Here, the two plus or minus signs are independent of each other. So, numerator may be positive, denominator may be negative, any combination you can consider. Theorem, L'Hospital rule. For limit x tends to a f of x upon g of x of the indeterminate form 0 by 0 or infinity by infinity. So, limit x tends to a f of x upon g of x is equal to limit x tends to a f dash of x upon g dash of x. So, here dash indicates derivative. So, if your given fraction is in 0 by 0 or infinity by infinity form, then you can take derivative of numerator divided by derivative of denominator. If again limit x tends to a f dash of x divided by g dash of x exists or equals to infinity or minus infinity. There may be instances where we would need to apply L'Hospital's rule multiple times, but we must confirm that limit x tends to a f dash of x upon g dash of x is still indeterminate before we attempt to apply L'Hospital's rule again. L'Hospital's rule is also valid for one-sided limit and limit at infinity. Now, let us see the application of L'Hospital's rule at indeterminate form 0 by 0. Evaluate example number 1. Limit x tends to pi, numerator x square minus pi square whole divided by sin x. Solution. We use L'Hospital's rule. Since the numerator and denominator both approach 0. So, if you substitute x equal to pi in numerator, it is pi square minus pi square, that goes to 0, and sin pi is also 0. Hence, this is of the form 0 by 0. So, let us apply the L'Hospital's rule, and that's why it is limit x tends to pi, derivative of numerator, derivative of x square is 2x minus 0 whole divided by derivative of denominator, that is sin x derivative is cos x, which is equal to putting value of x to be pi in numerator as well as denominator, we will have it as 2 pi divided by cos pi, and that is minus 2 pi because cos pi is equal to minus 1. Now, let us see L'Hospital rule and indeterminate form infinity by infinity. So, example number 2, evaluate limit x tends to infinity, numerator is 2x square minus 3x plus 7 whole divided by x square plus 47x plus 1. It is polynomial divided by other polynomial. As x goes to infinity, both the numerator and denominator go to infinity. So, we may apply L'Hospital's rule. Just substitute the value of x here and we will get it as the numerator infinity and denominator same as infinity. So L'Hospital rule says that you have to consider derivative of numerator and then derivative of denominator separately, and hence limit x tends to infinity, numerator derivative is 4x minus 3 divided by denominator derivative is 2x plus 47. In the second question, it is still the case that the numerator and denominator both go to infinity. So, we are allowed to use L'Hospital's rule again. So, once again we have to use the rule, and let's have the derivative of numerator. Derivative of 4x minus 3 is 4, and derivative of denominator 2x plus 47, derivative is simply 2. Now, here we don't have term of x at all. So, there is no question of substituting x is equal to infinity in this term. It is a simple constant term, 4 by 2, which is 2 simply. So, here we have applied L'Hospital's rule twice. So, you can use the rule if necessary, but before application of the rule, each time you have to check for the form, if it is 0 by 0 or infinity by infinity. I have referred a text of Applied Mathematics by N.P. Bali, Ashok Saxena and S.N. Iyengar. Thank you so much for watching my video.